In this section of the course, we're going to cover the basic principles and concepts of cloud storage. As we go through this section, we're going to have a singular focus on Domain 1, Cloud Concepts, and specifically Objective 1.3. This objective, Objective 1.3, states that you must be able to identify cloud storage technologies and, specifically, it lists out the features of cloud storage, the characteristics of cloud storage, the types of cloud storage, the use of software-defined storage, and the use of content delivery networks, which are known as CDNs. Now, as we begin this section, we're going to first discuss the three features of cloud storage, including compression, deduplication, and capacity on demand. Now, compression is used by cloud storage providers to reduce the amount of storage space needed to store data in a cloud-based storage system. By using compression, cloud service providers can provide lower storage costs for their users, as well as speed up the overall data transfer rates used inside of these cloud storage solutions. Deduplication is another feature of cloud storage. Deduplication is a technique that's used to eliminate duplicate copies of data that's being stored in the cloud in order to save storage space and reduce your storage costs. Capacity on demand is the final cloud storage feature we're going to discuss, and it allows for cloud storage providers to offer the ability to scale storage capacity upwards or downwards as needed so that users are only using the storage they actually need and are only paying for that storage that they're using. This can be really useful for businesses that have fluctuating storage needs so that they're only going to be paying for the storage they're actually using and they're not paying for unused storage capacity. Next, we're going to discuss the different storage characteristics that you need to understand for the exam, including performance and the differences between hot and cold storage. The first key characteristics of cloud storage is called performance, and performance refers to the speed and efficiency at which the data can be accessed and transferred. This includes factors such as data transfer speeds, the responsiveness of the user interface, and the ability to handle large numbers of concurrent users or requests. High-performance cloud storage systems will typically use a combination of advanced technologies such as caching, load balancing, and content delivery networks to ensure fast and reliable access to all of the data. Additionally, providers may offer different storage classes such as hot or cold storage, and each of those will have different performance characteristics that will meet the different requirements for workloads based on the cost and requirements and access patterns that you're going to have. Now, we talk about hot storage. This is designed for frequently accessed data. Typically, it has low latency and high performance requirements. This type of storage is typically more expensive than using cold storage, but it is necessary for applications that require fast access to frequently used data, such as things like databases or virtual machines. Cold storage, on the other hand, is designed for infrequently accessed data, and it typically is going to be used with lower performance requirements, and it gives us a lower cost. This type of storage is really suitable for archival data, backups, and other types of data that are not frequently accessed. Cold storage is less expensive than hot storage, and it can be used for long-term storage of data that's not accessed very often. After that, we'll discuss the different types of cloud storage that you can utilize. The different cloud storage types can be used depending on your specific requirements of your application or workload that you're trying to support using different cloud technologies. This can include object storage, file storage, or block storage. First, we have object storage. Now, object storage is a type of cloud storage that's optimized for storing large numbers of unstructured data objects, such as images, videos, and files. Object storage uses a flat address space, which allows for unlimited scalability and is often used for large data sets, such as backups and archives. Second, we have file storage. Now, file storage is a type of cloud storage that's going to be optimized for storing and sharing files. It allows users to create a hierarchical file system and then organize data into folders and subfolders, similar to how files are being stored on your local computer. File storage is often used for file sharing and collaboration, and it's accessed via protocols like SMB or NFS. Third, we have block storage. Block storage is a type of cloud storage that's optimized for storing and accessing data at the block level. This provides low latency storage for input-output intensive workloads, such as databases or virtual machines. Block storage is often used for applications that require a fast and predictable performance, and it can be accessed via protocols like SCSI or iSCSI. Then, we're going to move into our discussion of the concept of software-defined storage, known as SDS. Now, software-defined storage is a method of managing and provisioning storage resources using software rather than using specialized proprietary hardware. With software-defined storage, the system's storage functions are abstracted from the underlying hardware and are instead controlled and managed by software. This allows for greater flexibility and scalability because storage can be easily provisioned and allocated whenever you need it. After that, we'll discuss content delivery networks, which are known as CDNs, and we'll talk about how CDNs are used with cloud-based services. Now, a CDN, or content delivery network, is a system of distributed servers that are deployed in multiple locations around the world. The goal of a CDN is to serve content to users from a server that is geographically closest to them in order to reduce the latency and improve the overall performance of the content delivery. Now, finally, we're going to perform a quick demonstration so you can see how all these cloud concepts are applied in the real world, and then we'll take a short quiz to see what you learned during this section of the course and review each of those quiz questions fully to ensure that you can explain why the right answers were right and the wrong answers weren't. So let's go ahead and start discussing the different types of cloud storage and its usage in this section of the course.